Raptorex kriegsteini is an interesting tyrannosaur specimen with quite a bit of uncertainty and discussion around it, particularly with its taxonomy and time period. The main reason for the uncertainties was because the fossil was taken illegally by a collector before it was acquired by scientists. The location and age of the rocks the fossil was found in are often as important as the fossil itself, telling you when it lived, its ecosystem, and its specific relationship to other animals. The fossil was originally thought to be early Cretaceous, when it's actually late Cretaceous. To understand why this caused confusion, let's look at the tyrannosaur family. The early tyrannosaurs, called tyrannosauroids, such as Guanlong and Dilong, have many different physical traits compared to the later tyrannosaurs, called tyrannosaurids, such as T-Rex. Raptorex has many of the derived features of Tyrannosauridae. For example, two small fingered arms, unlike the long three-fingered arms of the early tyrannosauroids, tyrannosaurid-like teeth, what's called an arctometatarsus structure in the foot, fused elements of the gastralia, and more. This initially led experts to believe that the derived traits developed much earlier in tyrannosaur evolution than they actually did, when the tyrannosaurs were still mostly small animals. This was considered an important insight into the tyrannosaur evolution. This was of course later shown to be incorrect when the fossil was re-aged into the late Cretaceous in a 2011 paper. The authors of said paper did this by analyzing a fish vertebrae found alongside the Raptorex fossil. From this, experts saw that the derived tyrannosaurid traits in Raptorex didn't show an early evolution of this body plan predating the body mass increase, but instead these traits developed later alongside the body mass increase. The 2011 paper also re-aged Raptorex itself. Bones tend to change throughout growth, so juvenile and adult bones do have differences. This is what both the 2011 and original 2009 description paper looked at. The original 2009 paper suggested that Raptorex was about 5 to 6 years old, close to fully developed, and would probably not have grown past 3 meters long. However, the 2011 paper re-examined the histology of the specimen. The paper found that Raptorex was most likely a 2 to 3 year old juvenile. They additionally found that Raptorex was not close to fully developed and had a lot of growing left to do. However, while Raptorex was now re-aged, and definitely within the Tyrannosauridae family, there was more to discuss about its taxonomy. The 2011 paper that re-aged Raptorex also argued that it wasn't a valid species. The paper did not find enough differences between the fossil of Raptorex and a similarly sized juvenile Tarbosaurus fossil to confidently identify them as two separate animals. Specifically, the paper looked at the reported differences between Raptorex and the young Tarbosaurus specimen. One of the reported differences between the two was that Raptorex did not have a small crest on the ilium bone of its hip. The paper found this to be incorrect and that the crest was in fact present. Then, two previously reported differences in the skull of each animal were potentially, though not conclusively, due to interspecific variation, meaning that these were potentially traits that would vary between species, just like how all humans or all cats or all dogs have skull differences. Thus, these two traits were treated as unreliable to properly differentiate Raptorex and Tarbosaurus. From all this, the authors concluded that based on the lack of certainty over where the fossil comes from and its juvenile status, the Raptorex specimen was an unreliable holotype. Therefore, the paper stated that Raptorex should be considered an invalid species, or nomen dubium, and hypothesized that it was potentially a juvenile Tarbosaurus, though the paper did not state this as a fact and said that the hypothesis should be tested. In 2013, there was a paper that looked at the Tyrannosaur family in general. However, they did not find that Raptorex was a young Tarbosaurus, instead finding it to be distinct as its own genus and species. Since then, there have been two papers published, which took a closer look at that previously mentioned fish vertebra. The first, published in 2013, found evidence that the vertebra, and therefore Raptorex, were both from the Nemegt Formation. This is the same formation the Tarbosaurus BATAAR fossils are found in. A later 2022 paper again looked at the vertebrae and found additional supporting evidence that it was indeed from the Nemegt Formation. We still don't know, per se, that it's from the Nemegt, but it's very possible. It is therefore not certain, but quite possible that Raptorex and Tarbosaurus did live at the same time and at the same place. Finally, in 2023, a new paper restudied Raptorex again. From this reanalysis, the paper agreed with much of what the 2011 paper had said about the age and time period of the animal, but importantly, it did not find support for the juvenile Tarbosaurus hypothesis. When looking at the skull, the paper found 5 features that were different in Raptorex compared to other known tyrannosaurids. Specifically, 4 of the features were traits that had not been found in any other tyrannosaurid, adult or juvenile, and the 5th was the lack of a flange on the maxilla bone. The presence of this flange is one of the defining traits of Tarbosaurus, present in all juveniles and adults. Therefore, the paper found these unique skull characteristics to not be interspecific variation, and instead enough to reliably distinguish Raptorex as its own genus and species. Thus, it and Tarbosaurus were found to be 2 different contemporary species. So that's Raptorex. The most recent research does show it to be distinct from Tarbosaurus. As far as I know, this could change in the future, though the 5 distinguishing features do seem like very solid evidence to differentiate these 2 animals. Until next time, thank you for watching.